Hi, this is Mrs. La Barbara. Today's topics are instantaneous speed, velocity, and relative speed and velocity. The objectives for today is to know the difference between instantaneous speed and average speed. To understand the speed of velocity is relative, to be able to determine relative speed or velocity. Instantaneous speed. Instantaneous speed is the speed at any given instant in time. For example, in your car, the speedometer tells the instantaneous speed. So during your trip, for instance, a car over here, it can have different speed at a different time. So during your trip, there may have been times that you were stopped, and other times that your speedometer was reading 50 miles per hour. Yet on average, you were moving with a speed of 25 miles per hour. So as you can see, average speed is different from instantaneous speed. How do we determine instantaneous speed? We use the same equation as average speed. So average speed is total distance divided by total time, or change in distance divided by change of time. Instantaneous speed has the same equation, except when the time interval is extremely small, when delta t approaches to 0. Here is an example of kind of like instantaneous speed. So the graph below shows Donovan Bailey's split time for his 100-meter record-breaking run in the Atlanta Olympics in 1996. So as you can see, during each time interval, his speed is different. So it's kind of like instantaneous speed is different from average speed. So at what point did he experience his greatest average speed for a 10-meter interval? Since each interval has the same 10 meters, so when the time interval is the smallest, that's when his speed is greatest. So the time interval is smallest during 4.9 to 5.6 seconds. Calculate this speed in meters per second. So that speed is distance divided by time. Distance in this interval is 50 minus 40 meters, so the 10 meters is the distance, and the time interval is 0.7 seconds. So the answer is 14.3 meters per second. That is the average speed only in this interval. When this time interval, I change it, instead of 0.7 seconds, if I change that into 0.1 seconds or 0.01 seconds, that's closer to instantaneous velocity at that time. What was his average speed for the overall race? His average speed is total distance divided by total time. Total distance is 100 meters, total time is 9.84 seconds. The answer is 10.2 meters per second. As you can see, the average speed for the total run is different from the speed in each time interval. This is kind of like instantaneous speed. Constant speed versus changing speed. What does constant speed mean? Constant speed, it means the object covers the same distance for each regular interval of time. Take a look at this. From 0 to 1 second, the object covered 6 meters. From 1 to 2 seconds, another 6 meters, and so forth. For each second interval, the object covered 6 meters. Therefore, its speed for each second is the same. On the other hand, an object moving with a changing speed, that means it covers different distance each second. From 0 to 1 second, it only covers 1 meters. From 1 to 2 seconds, it covers 3 meters. From 2 to 3 seconds, it covers 5 meters. From 3 to 4 seconds, it covers 7 meters. Therefore, its speed is increasing. Speed is changing. Changing speed, constant speed. Relative velocity. Relative velocity is velocity seen by a particular observer relative to that observer, or simply relative velocity. Take a look at this example. The planes are flying relative to each other, as you might have seen in an air show. What is the plane speed? Relative to each other, the pilots, the planes are almost at rest or moving at a very slow speed. However, relative to the observers on the ground, the planes are flying at a great speed. Example, a train is moving east at 25 meters per second. A man on the train gets up and walks toward front at 2 meters per second. What is his velocity? Well, it depends on what we want to relative his speed to. Who is looking at him? So if I was a passenger on the plane, then I see he is moving at 2 meters per second. However, if I were a person standing on the platform, I will see his speed is 27 meters per second. Another example, a passenger on 747 that is traveling east at 230 meters per second walks toward a lavatory at the rear of the airplane at 1.5 meters per second. What is a passenger's velocity? So again, it depends on who is looking at a passenger. So if I was another passenger sitting on the plane, then this passenger would be moving at a negative 1.5 meters per second because he's going backwards. However, relative to somebody on the earth, if I'm to look up and I can see, I can measure, his speed would be 228.5 meters per second because he's going backwards and the airplane is moving forward. So he's moving slightly slower than the airplane. Here is another example. You're driving north on a straight 2-lane road at constant 10 meters per second. A truck traveling at a constant 50 meters per second approaches you in the other lane, fortunately. So you are 50 meters apart. To draw a picture, it would look like this. Here's a truck driving toward you, and here is you driving toward a truck in another lane. What is the truck's velocity relative to you? Since you are traveling toward each other, so the speed is much greater relative to each other. You're adding them together. The truck is traveling toward you, which is going to south, 25 meters south. What is your velocity with respect to the truck? You are going north at the same speed, 25 meters per second north. When will you pass each other? So you're trying to find one, which is time. We use this equation, v equals d over t. Remember, v and t can be exchanged. So t equals d over v. The distance between you two is 50 meters, and the speed relatively to each other is 25 meters per second. So it's in 2 seconds you will pass each other. How do the relative velocities change after you and the truck have passed each other? The velocity doesn't change. So except instead of traveling toward each other, you will travel away from each other. Now here is another scenario. A truck is driving north in a straight 2-lane road at constant 10 meters per second. You are also traveling north at a constant 50 meters per second. So you are 50 meters behind the truck. So draw a picture. Here's the truck, 10 meters. You are traveling at 50 meters per second. You are 50 meters behind the truck. What is truck velocity relative to you? Since truck is traveling at a slower speed, so you are catching up with truck. So relative to you, the truck seems traveling toward you at 5 meters per second. South. What is your velocity relative to the truck? You are like catching up, but you're catching up slower because you are traveling in the same direction as the truck. So you are traveling relative to the truck is 5 meters per second north. When will you pass the truck? So again, it's the time. Similar to last question, you're solving for time is d over v. So the distance between you two is 50. The relative velocity is 5. So the answer is 10 seconds. How far have you traveled when you meet? Well, you're trying to find d. d equals to v times t. So how far have you traveled? You have to use your speed times 10 seconds. So that gives you 150 meters. How far has the truck traveled? You use truck speed times time. So truck has traveled 100 meters. So how do the relative velocity change after you and the truck have passed each other? So again, velocity doesn't change, except you're going further and further apart. So now two cars, A and B, starts out 300 meters apart. So car A travels due east toward car B, and car B travels due west at 20 meters per second, and car A travels 30 meters per second. So again, to draw a picture, you have 30 meters per second, 20 meters per second. Here's A, here's B. They are 300 meters apart. So how long does it take before the two cars meet? You're solving for time. D is 300 meters, so relative to each other, because you're traveling toward each other, the speed is faster. You add the two together, you'll have 6 seconds. Another example, car A moving in a straight line at a constant speed of 20 meters per second is initially 200 meters behind car B, moving in the same straight line at a constant speed of 15 meters per second. So here is the picture, B 15, UA 20 meters per second. It's 200 meters apart. How long does it take before car A catch up with car B? So again, you use time is distance divided by relative velocity. Because you're traveling in the same direction, relative velocity, your sub is the difference between the two. So 200 divided by 5, you have 40 seconds. How far must car A travel from this initial position before it catches up with car B? How far is the distance? So distance is V times T. Since the distance is car A, so you must use car A's speed times the time, which give you 800 meters. That's it for today. See you next time.